Okay, so here are some instructions for the lab. Hopefully they are slow enough that you understand what you need to, but fast enough that you have time to do the lab. By all means, if you have questions, do not hesitate to ask. Um, so this is the air resistance and terminal velocity lab instructions. You should also follow the handout that is posted on Canvas, and it includes these instructions. Connect the data logger to the computer, that is a green box. Connect the motion detector to the data logger. Those two are already done for you. Support the motion detector 2 meters above the ground. It will be about 2 meters. Open Logger Pro, have partner hold 1 to 3 coffee filters, and so forth. You should read through those instructions. What I'm going to do is add some clarifying comments. So the first thing that I want to talk about is the setup. Right here, we have the motion detector, and it is attached on a bar, and you want to make sure that this is extended out as far as it can possibly go. It's on a ring stand, and in order to get it as high as possible, I've placed the ring stand on a blue box, which should be at your station. The other thing that you want to note is that I have the cord going behind the clamp so that it's totally out of the way when the coffee filter falls. That is connected to the data logger, which we just see the tail end of it here. It's green. The data logger is plugged in. It has two cords coming off of it. One goes to the computer behind, and then the other is a power block that goes to an outlet. So that is the setup. And the other thing you'll notice is that I have the ring stand hanging off the edge a little bit so that again we have a clear path when the coffee filter drops, that it doesn't run into the edge of the table or to the ring stand. It has to drop without being knocked at all. Okay, so that's the setup. The software that you're going to open is Logger Pro, and here is the icon for it, and you just open it up. And if everything is connected correctly, this is what you will see. You'll have a graph of position versus time and a graph of velocity versus time, and there will be two graphs. If there are not, you want to stop and ask me what's happening, and most likely it's just the connections on the data logger or the motion detector are not accurate. Ooh, one more thing about the motion detector. This is, you can motion or move it so that it's out. You want to have this so that it's parallel to the floor or perpendicular to the direction of travel. So, okay. Um, the next thing on the instructions, so you are going to drop coffee filters, and you do not want to put them right on top of the data logger. You want to have about 0.3 meter gap between the bottom. You're going to hold it up, and one of the partners is going to press this green button for start, and you will hear little ticks coming from the motion detector. As soon as you drop those ticks, you want to pull your hand away, um, and you want to make sure that you don't get in the path of the ticks at all. If the coffee filter does not fall straight down, you'll have a really bad run and you'll have to start it. So it may take you a couple of them to get a good run. So what does a good run look like? So first of all, I want to note the parts of the run that you are concerned about are going to be, this is where it's at the top, this is where you let go of it and it starts to fall. So this is the only portion of the graph that you want to look at. You want to ignore everything else. So you want to ignore all that, ignore that, ignore that, ignore that. So when it says draw, ignore all of that. The only parts that you want to draw are like right here, okay? Everything else is not important. Okay, so this is a good run. Notice that I have a smooth curve on my position versus time, and I've got kind of a smoothish, I'm just going to show you, we know what graphs look like, so I'm just going to remind you. This is a constant slope up, and even though there's some bobbles, we're going to call this flat. So this is straight and slanted. and this portion is flat, and that's what you're going for. Now, it's miraculous when you got that. Typically, what you will get is this is a bunch of lines going up and down, which means that either the coffee filter was not dropping perfectly flat, or your hand was catching in it, or something was going on. And what really is the killer is that I've got some like up and downs on my velocity, so I'm not going to get a really good read on my velocity. So you're going to have to do the run again. It only takes like 3 seconds to do each run, so not a big deal. Now, this one, is this a good run? I'd actually say this is okay. So even though there's a bobble, I can still tell that this is a pretty straight line. Um, I can like use my tangent tool and see that that's not too bad. I've got a pretty straight slope up, and so forth. So that one's not too bad. Um, Okay, the last thing I want to show you is that you are directed to use the tangent tool because we want to find out values of acceleration. So the tangent tool is this one right here. If you hover over it, you'll get this thing that says tangent. And what you will find is there will be a black straight line that appears on both of them. What you are going to do is you are going to move your mouse back and forth along this line, and it's going to give you values. Here's where we have to remember. So it's going to give me the tangent or the slope of the line on position versus time. That the slope of position versus time is equal to a variable. Very important one, you should know that. And you will also use the tangent tool on remember this is velocity versus time. So we'll also need the slope of velocity versus time. And again, that is equal to a variable. When you are filling out the worksheet, you will need to know which slope do I want, position versus time or velocity versus time. Because if you choose the wrong one, you will get the wrong stuff. So you can consult with me as always. So as I said, hopefully we have hit that Goldilocks sweet spot of not too long, not too short.